Can you hear me? You're muted. Jessica? Unmute my audio. There we go. Can you hear me now?
Jessica Williams.
Oh, God.
Hello, everyone, and welcome. My name is Jessica Williams, Programs and Community Partnerships Manager at Chabot Space and Science Center, and we are thrilled to bring you another exciting virtual program from your homes this evening. Thank you so much for tuning in, everyone. Please consider making a donation tonight to help us keep these free programs accessible and engaging to all. You can make a difference in less than a minute when you support STEM education right on our website or here in the link below. Tonight we have with us Faride Khalaf, who will take us on an ultimate lunar camping trip. Faride is a retired career aviator with a passion for all things mechanical. His lifelong love of science has driven him to studying and sharing the history of space exploration. As an airplane pilot, he's done his fair share of airplane camping and is an aircraft mechanic. He plans for his travels with safety in mind. Thank you, Faride, so much for joining us. How are you today?
I'm doing fine, Jessica. Good evening. And thanks everyone for joining us tonight.
Thanks for being here. And
yeah,
isn't it true that you were a longtime volunteer at Chabot, and of course still a longtime friend of Chabot, but you were a volunteer for a few years.
That's true. Yeah, it's a wonderful place to work, and great people. Great people.
Faride, are you able to turn your video on so we can see you?
Yeah, I'm ready to share. And
if you want to go ahead and turn your camera on.
Camera is, whoop, it just disappeared. The screen, come back. Here we go.
There we go.
Hello.
Wonderful.
Okay,
well, thank you for being with us. Thank you for doing this talk tonight.
You bet. I'm glad to be on. Thank you. So I'll tell you a little bit about tonight's program. It's something I put together myself. One of my many hobbies is camping and backpacking, and I like car camping. I just love the outdoors. I like boat camping, canoe camping, airplane camping, anything like that. I'm the kind of guy who rents a motorhome to go camping, and then I'll pitch a tent as far away from the motorhome as I can, just because I'm there to be in the outdoors. So tonight we're going to take a trip to the moon and also to the woods and draw a comparison between the two experiences, the environment, the dangers, the surprises, and a lot of unknowns in both of these endeavors. So think of tonight's program as a kind of a workshop on imagining, trying to work through a problem without experiencing the problem, but imagining it. It's kind of like a simulation. If you don't have access to a multi-million-dollar simulation for an airplane, the next best thing to do is close your eyes and sit in a chair and imagine an emergency and how you would react to it. Because if it ever happens, you've at least rehearsed it and you're familiar with what to do, and that will keep you from panicking. Panic is kind of a bad thing to experience because it will get you in trouble, and it doesn't help you to think straight. So remaining calm and having the confidence and training and experience, each time you do this, you get better at it and you discover newer things, and it gets to be a lot of fun. So without further ado, let's see if we can get you on the program. So how are we doing, Jessica? Are we on?
Looks great, Faride.
Looking good? Okay, I wanted to make sure. Okay. Oh no. This is not supposed to happen. Sorry. My cat just jumped on the computer. He leapt from 5 feet away and landed right on the laptop. So here we go. This opening picture has a story. On the left, you'll see a backpack that was made by a person that carried it 200 miles. This man, his name was Alonzo, and he looked like Santa Claus, and he was 70 years old. And the prior year, he had quadruple bypass surgery, and his 90-year-old mother was not happy when he decided to go hike from Bishop, California to Yosemite Valley. It took him 2 weeks to cover 200 miles, and 60% of his food intake was fish that he caught along the way. So I was very impressed, and to hear his story, I treated him to lunch, and we exchanged a few letters afterwards. So our journey is going to begin in Yosemite. The next slide shows the shadow of astronaut on the lunar surface. And some people think that this stuff was faked. And I want to tell you, it's not, despite what people say, okay, yeah, maybe it was filmed in a studio, but that studio was actually built secretly on Mars. So that's an accomplishment in and of itself. To the right, that was just a joke, of course. To the right, a very different kind of environment. The sun angle is about the same. And I had this picture from one of the Apollo missions in mind when I took this photo, and thought side by side, it's a good contrast between a very hostile environment, very hostile to life as we know it. And the life we're most familiar with is our own. And on the right is the planet that everyone you ever knew, everybody you ever read about in history, every hero, everybody, past, present, and to a great extent, our future. We hope our home will sustain us long into the future. It would be a shame to live with just a memory of planet Earth, no matter where we go. But I suppose wherever you are, that's home. So people might not miss it. They might have it better. Terraforming and things like that. This is what I'm talking about, imagining. Don't just be an Imagineer, be an Imaginator, you know, really go the distance. And if you think these ideas kicking around a campfire or a boardroom, these vast variety of questions and ideas are discussed. If you think you have a dumb question, you've all heard this from your teachers. There's no such thing as a dumb question. If you heard some of the things that they talk about at these meetings, you wouldn't believe it. They talk about everything you could possibly imagine. And the more I delve into space history and look at archival pictures and read about things, the more I realize how varied all the schools of thoughts and the archetypes and the ideas were. So many ideas to pick from. And of course, they picked the best they could for the mission each time. Now, if you're going to go away from home, you're going to need certain things to take with you. Here on Earth, if you're going to go on a business trip, you pack a suitcase. You try to pack it as neatly as you possibly can. Now, neatness doesn't always end up being the result when you're packing, especially in a hurry. But if you plan things, you pack things so that everything is in the right place. Now, there's a saying among sailors, a place for everything and everything in its place. This is a motto on pretty much every naval vessel. And where I read this first, this little proverb, it's on a plaque on a three-masted schooner with a steel hull. It's called the C.A. Thayer, and it's at the National Parks Run Maritime Museum in San Francisco on Pier, I think it's Pier, Hyde Street Pier. It's not a numbered pier. That's where I had a hiccup. So you get everything packed really nice and neat. If you are going on a mission paid for by taxpayers, you don't have a choice. And you don't get to decide everything that goes and what stays behind and what goes with you. It has to be planned out meticulously. And you can even do innovative stuff like pack a vehicle in a suitcase, like a bicycle, a foldable bike. But this idea is not too far off for what they did with some of the Apollo missions, the last three to be specific. That's 15, 16, and 17. We took cars up there, and that's coming up in the next slide. Now, the quantity of baggage you can take with you varies based on your mission and how long you're going away for. Here's what you have to pack when you go to the moon. You have to pack drinking water. You have to pack the air you breathe. You have to pack certain medicines, and typically astronauts that go on these trips aren't on a lot of pills. They don't have, you know, cardiovascular issues that would become a liability for the crew and the success of the mission. So they need really healthy people, people who don't exceed certain medical parameters. Weight is really critical so that you can carry more useful load, things like food provisions, extra fuel. And the amount of fuel you have to burn just to carry 1 pound is mind-boggling. To give you an idea, on the Concorde, which was retired in 2003, made its last flight, that's the European co-venture between the British and the French. Back in the 70s, they designed a supersonic passenger airplane. Now, this is history for you young people, for millennials, but I've seen them, I've been on them. I almost got to fly on one, but I missed that opportunity, and it's gone. It's relegated to history forever. And just to take 4 extra passengers, you have to burn 2,000 pounds of extra jet fuel. So just the weight, your baggage weight costs the airline money to carry it across the sky, because you're fighting against gravity to keep this stuff from falling back to Earth. And the more you carry, the more fuel you need to produce more power to keep that mass from accelerating back to Earth. So that's how you get to cruise at high altitude. So one more thing I want to say about this slide. I took my friend and my sister's friend airplane camping to a town called Columbia. That's in California, in the foothills in Gold Country. Some of you may have been there. It's a state park, it's historic, it's kind of a neat place to visit, very hot in the summer. And my sister brought a blow dryer, and weight is critical, especially in a small airplane. So I had to disappoint her and tell her, even though there's electricity in the campground, I can't really justify carrying the extra weight for safety reasons. So let's move on. So not too much baggage. Now, that little bicycle you saw folded up and tucked into a suitcase, they did something very similar in NASA. What you're looking at is a completely folded, like a transformer, a 4-wheel drive electric battery-powered vehicle. It's an all-wheel drive. It does not have rubber tires because they're heavy. So they used a steel mesh with spring battens inside of it that act like belts in a tire. And keep in mind, you're in an environment where the force of gravity is 1/6 of Earth's gravity, and you don't have to worry about how much weight the tires need to support. So you could build a very flimsy looking vehicle, and it's not a speed racer. It didn't go very fast, but it took a load off the astronauts in their mission, so they didn't have to burn up their oxygen supply real fast walking, because that takes a lot of energy. And here the NASA astronauts are testing the deployment of this device. And it's believe it or not, gravity has a role in how this thing opens up. You pull a thing and the mesa opens. Mesa is the table that this thing is attached to, and it drops to the ground. And it's a clever device that they used. It cost $6 million. No, they built 6 of those at the cost of $48 million. Back in those days and to this day, the most expensive automobiles ever built are the lunar module, the lunar, what they call, not buggies, they called them rovers. That's it. Now in this slide here on Earth, I'm all by myself, and I actually had a little bit of a mission control thing going. And I'll get into that. But if you look at this slide, you can see where I'm pointing to my tent way in the background. And this is my food supply. And as of the last 15 or maybe 20 years or so, they require you carry a bear-proof container. So this is not an issue when you go to the moon. You don't have raccoons, mosquitoes, or you know, anything like that to worry about. But you do have to worry about the air you breathe. You have to manage it. You have to make sure that all the systems that provide that air are functioning properly. And you're not alone in doing this. You have people on Earth monitoring everything through telemetry. And telemetry, for some of you who may have heard this term but not know what it means, tele means over distance, like telephone means speaking over distance. Phone is audible sound. So sound over distance. Telemetry comes from meter, metri. It's Greek in its root, and it means measurement. So measurements over distance. So through radio transmitters and processors and switches, rheostat sensors, thermistors, and thermocouples, and all kinds of cool bimetallic strips, any kind of heat sensitive, mechanical motion sensitive, force sensitive device can trigger a reading and a processor, and that gets interpreted by engineers. So while you're sleeping on the moon as an astronaut, there are people working around the clock, making sure your heart rate is perfect, that you're breathing. You have a lot of guardian angels. They're just not in the spacecraft with you. So, but imagine not having that support and being out really alone, not just in a small tent, but in something about the size of that tent, 250,000 miles away from home. That's something to think about. Now, we went from a very beautiful green, lush environment of Earth to the lunar surface. And what you see is a lot of craters and very small craters. These are microcraters. Most of these craters are not micrometeors or meteorites, rather, from space. A lot of this is the ejecta, the material that's blasted out of the crater when a large meteor impacts. And what happens is, just like an aerial bomb from World War II, if you've seen those in movies, it blows a huge crater. And incidentally, if you Google Earth, a lot of the farmlands around Peenemünde, which is in northern Germany on the Baltic Sea, where they built the V1 rockets, that was a very dangerous weapon to the Allies in World War II. And we had to destroy their capacity to build and launch those weapons at our friends in London. And in the process, we bombed the heck out of that area with our B-17s, and the British did the same with their Lancasters. And to this day, some of those bomb craters haven't been filled. And you can see them, they're pockmarked all over the cornfields, and some of them are holding water and cattle will drink from it. So some yielded a purpose. Well, these tiny craters are made by the same physical phenomenon. And when that ejecta falls back down, it accelerates because there's no air resistance on the moon. There's no terminal velocity. So things just keep accelerating until they impact. So the ejecta, when it's falling down, it picks up a lot of speed and makes these little craters that are peppered everywhere. And that's common on the lunar surface. Those are just the tiniest ones. Back to Earth. So you can see right here, that was my space toilet. This here is my little space blanket. Those of you who grew up in the 60s, remember that TV show, Lost in Space? Um, everything was covered in aluminum foil back then and Mylar film. Their spacesuits were made of the same material. Everything shined. Even our Mercury astronauts had to wear shiny suits because that's what TV introduced us to. Spacemen wear aluminum foil. And after a couple of Gemini missions, NASA realized this is dumb. And that's when we started using white spacesuits. They're practical and much better for protecting our astronauts. So there's my backpack that I carried to the top of Yosemite Falls, which is a long hike. It's a 5,000 foot elevation gain. Did that in the same day. I take my time. I'm not a speed hiker, but I really enjoy the experience. When you go out into the wilderness and you find a nice little place for yourself, it's paradise. It's a place to clear your head and commune with nature. I had a friendly spider that pretty much lived in my tent with me for 3 days. So I wasn't alone at all, really. And I imagined a mountain lion that lived on the rocks where earlier you saw my food storage. And I wish I could see that lion once. Lions are more scared of us than we are of them, but still, they're dangerous. Okay, so look at all those trees, the rocks, how beautiful it is. This was the big rock near me. It has a hole in it. And I don't know what process causes that hole. But if you could look real close on this, well, it's not a tiny rock, but compared to the next slide, it is. This rock is teeming with life. There's all kinds of fungal growth on it. There's lichens and all kinds of algae and probably teeming with microscopic life that you can't see. And of course, all around, there's plenty of examples of life. Now, I know I can survive on Earth for a while, as long as I have water, air, and, well, air comes with the planet, thankfully. And yeah, it's included. And I know I can eat some of the vegetation, especially pine nuts. But if you ever eat the pine nuts in the wild, be aware of squirrels. They get angry at you because you're taking away their food. Now, here's a fun fact about squirrels. 80% of the nuts and whatever it is that they hide for later, 80% of it they can't find later on. So they're forgetful, but they don't want you to take a single one of those pine nuts out of their food supply. I just think that's kind of a funny irony there. Now, the next rock is close in shape, but it's actually much larger. It's about 10 times the volume and height and mass of the rock that I showed you in Yosemite. But look what's around it, nothing. It's absolutely lifeless as far as we know. We haven't gone back since the 60s to discover more life, actually early 70s. So it's time we go back and see what we can find. I'm sure we missed some details. Water is critical. You can see here on my day hike, because what I did is I set up a base station. That tent was like my lunar module. And the surrounding environment was a lunar surface for me. And I would go on, 4 or 5 mile hikes in the daytime and then come back, make dinner, and get ready to go to sleep. Now, my mission control was ham radio. This was back a ways before cell phones. Actually, I did have a cell phone, left it in the car, didn't need it, because at that time, Yosemite had no cell phone coverage. And since I was going alone, my wife, Kathleen, was a little concerned. So to put her mind at ease, she's also a ham radio operator. And using the science of radio, pure radio, I connected with a group of men that like to meet every morning. These are retired men in Yosemite. They meet on a local repeater, and I would join in and for their roll call and I was known as Yosemite Sam. They called me, and they would check in on me every time they did a roll call. They'd say, "How's our fellow camping in Yosemite?" And they would email Kathleen for me, which was a big service. And can you imagine having that kind of capability? And it's completely all free from infrastructure. Radio is really awesome, and that's a whole nother subject. But here's what I do for water. You can see this filter. I've superseded this piece of equipment. This thing weighs over a pound. I think it's like 20 ounces. It's a clay filter, and it can take every harmful microscopic life out of there. And so it makes the water safe to drink. The one I carry now weighs 2.2 ounces. So that takes a lot of weight off my backpack. Hooray for me. More power bars, Snicker bars, whatever it is you take for food. And you should always take more food than you need. You'll end up sharing it with someone who's desperate. And also make sure you take salt with you. Salty foods are good on these trips. And don't ever go on a diet while you're backpacking. I've seen people do it. They become a medical issue. They bonk. If you're a bicyclist, you know what that means. You run out of energy completely. So here's a picture of the Lunar Module. That's their tent. The Apollo astronauts would sleep in there at night. Neil Armstrong is said to have had a hammock that he strung up in the Lunar Module. Now, bear in mind, you're hanging in a hammock with 1/6 of your weight. So you're kind of in a fluffy marshmallow bed in a sense. You're not going to get a lot of bed sores that way. It takes a lot more time to get the same kind of discomfort that you would feel from prolonged laying in a bed. But anyway, so yes, it may have been uncomfortable, definitely for Buzz, because Buzz Aldrin had to sleep on the floor around the engine cover for the ascent stage of the module. The ascent stage is from this part where the arrow is above, and everything with the landing gear stays behind. It's dead weight. So that's space junk for the moon. And you can see above the spacecraft, your nearest 911 first responder is 250,000 miles away in that vast distance. Everybody you know and love and hate, everyone that you ever came across in life, you're looking back at them on a half illuminated Earth. And can you imagine being that far away from home? You know, if one of those micrometeorites impacts into your spacecraft, it'll pierce the aluminum and you'll start leaking air. So you have to effect a repair or quickly don your spacesuit. These were potential hazards, but the mathematical odds were pretty astronomical, no pun intended. But with those kinds of odds, it's a safe bet. You know, every time you get in a car and drive, your odds of getting hurt, I think, are far greater, actually, than being hit by a micrometeorite as an astronaut. Okay, so that's far from home right there, huh? Now, the difference between going into space and going camping is, well, one is purely recreational, although going into space is a very I would think it's a psychologically and spiritually impactful experience. I get chills. I feel tingly right now just talking about it. Now, astronauts in space and on the moon made their work look so much fun and easy. Well, keep in mind, these people are in extremely good physical condition, healthy, and psychologically they're strong. These aren't the kind of people who panic. You saw the movie Apollo 13. The crew started to go off the rails a little bit and start arguing when Commander Jim Lovell said, hey, you know, you can bounce around the interior of the spacecraft all you want, At the end of it, we're going to end up right back here now. We need to get home. What do you want to do about it? So he maintained discipline, order, and a sense of calm that's very important in an emergency. You need a cool head, and cool heads prevail. That's why fighter pilots have to have nerves of steel. Very little phases, these people. Their training is intense. Astronaut training is very intense. They rehearse everything. As you can see in this slide, it takes a pretty hefty parabolic antenna to communicate with Earth. Now I can tell you, if you try to set up an antenna like this on Earth anywhere, it's probably going to collapse under its own weight because it's designed for lunar surface, although this is a simulation on Earth, so it's robust enough. But, you know, if you sneeze, you can knock it over. It's a big, like a parachute. It's got a lot of air resistance. So a light gust or dust devil could really do some damage to it. On the lunar surface in the vacuum of space, or in what we now know as the very faint atmosphere of the moon, this thing's not going to move. So it's perfect for that environment. And it's mostly made of metal mesh. But that had to be rehearsed, how to properly deploy it. And to simulate the conditions that you're going to be doing this in, you have to don your spacesuit, and they take a lot of weight out of it to simulate being on the moon, so it's not as heavy. But it's still pretty uncomfortable. They pressurize these suits, so you're actually working against internal air pressure of the suit, and that's exhausting. So they're really exercising you hard. These people, I'm sure, couldn't wait to get home and eat a huge portion of food after their busy day. They even rehearsed that one small step that Neil Armstrong took. And you can see here on the left side, that's a simulation of taking that first step and willed into solid reality. For anybody who thinks we didn't go to the moon, I'm sure we're going to have some pictures coming back from that very same footstep. Maybe not, but because it's not an important mission to go take a picture of that, but it would be it probably wouldn't convince the people who have convinced themselves that we didn't visit the moon. So we'll just keep moving on. And they also have to simulate everything else that they do in space. If you're not going to the moon, well, then you're probably going to low Earth orbit and eventually Mars and beyond, hopefully. And I won't be around to see it, but I think I can expect to see some kind of a mission to Mars. Even the unmanned missions to Mars are exciting. Our latest sister ship to the Curiosity rover, Perseverance, I think it's the name. It was just launched about a month ago. So we're going to have a really a spectacular event to look forward to. Hopefully, we will be in a safer environment to where we can be social and be back in the routine of visiting those places we love, like Chabot. I look forward to going back and seeing everyone in person. I've never done one of these before without an audience. So I feel like the crazy guy who sits in the corner and is talking to himself, but I don't even have an earbud. Now you're looking at various modules of the International Space Station. This is in Johnson Space Center. All the astronauts that we train have to go through these modules. The big difference is they're not in a microgravity environment. On Earth, it's impossible to simulate microgravity for prolonged periods of time. So we basically pretend it's microgravity and walk through these modules and do simulations of maintenance work. There's a lot of housekeeping up there. There's no plumber to call. Everyone has to, they take turns and clean the toilet. There are 2 toilets on this International Space Station, one made by the Russians, and theirs is a proven system that they used during their Soyuz, the Salyut space stations. And on the Soyuz, they had some portable equipment for the same purpose that you can find at Chabot Space and Science Center when they're giving a demonstration of the spacesuit. Ask them to show you the space toilet. It's part of that demo. It's kind of neat. Okay, this same arrangement of modules to the space station, they also have that in Baikonur. Actually, not at Baikonur, it's in Moscow. So the astronauts on the Russian side get trained using that module or that series of mock-ups. If you ever get a chance to visit Johnson Space Center, it's well worth doing. My cat just walked across the laptop again, but I didn't lose you. That's good. Now, there's that lunar module, or rather the lunar rover back in the day. It looks like astronaut Dave Scott, and that is Dave Scott facing the camera in the driver's seat. And the guy next to him, I can't tell who that is, but they had to simulate driving their vehicles on the lunar surface. So they took these vehicles to places like near the Grand Canyon, areas in Utah, and but mostly California. We have plenty of desert in California. And so they had to learn geology because real geologists, career geologists, didn't get the luxury of going up there. They had to be astronauts. But the very last mission to the moon carried with it the first scientist, American scientist. It was Harrison Schmitt, Jack Schmitt, who was on Apollo 17 with Gene Cernan as the commander. And I think it was Ron Evans that was the command module pilot. And that's the guy who sits in the getaway car that orbits the moon to bring you home. Think of him as a bus driver at Yosemite when you're done camping. You take the bus to get to the Amtrak station. And then the Amtrak train is like the command module orbiting. When you get on board, then you can go home and like back to Earth. And from the Earth, this is what we see on a lunar eclipse. An orange moon. And that is the conclusion of my presentation. And I have a few items of show and tell for you as well. So, okay. We are going to do some Q&A now. And while we get the questions in, I can do a little bit of show and tell until we get our first question. How's that?
Thanks, Faride. That was such an awesome presentation. Very thought captivating, and definitely want to go on a camping trip myself now. And
oh, good.
Now we know what we need to take to the moon if we want to go. We got a lot of comments from folks saying that they're ready to pack for their trips and they're getting inspired to go out once the air quality is better, of course.
Right.
So,
yeah, we have forest fires going right now, which isn't, it's not helping the situation we're in with COVID. So right. Thankfully, there's a lot of good stuff on YouTube, folks. There's so many beautiful places on Earth to visit, and you can save yourself a lot of airfare. You get to feel what it's like to be there. I've been doing a lot of canal cruising with YouTube in England on their narrow boats. Nice. It's a beautiful thing to watch. So
we can do
now,
in the world.
This is my friend Neil. He's made of foam rubber. As you can see, he's squeezably soft. He weighs about a few grams, so it's not a huge weight penalty to take him with me. And he is a NASA astronaut. And he has the orange stripes to prove he's commander. What's the point of this little figure? For one thing, at Chabot, we have a 30-foot tall rocket. It's a model based on the Saturn V that took the crew of the Apollo missions to the moon. And this is about the right scale for the astronauts who would fit in the very top in the command module. So I used to take this on tours and just show people, this is how big this rocket is. Here's the guy standing on the ground next to it.
That's amazing.
What what I like to do is take him with me camping and keep him in the tent. So if I start to get homesick or I'm not happy or I'm not comfortable, if something's bugging me, like maybe I'm scared of bears a little bit. Sometimes I get that way because you hear about bears that get aggressive. And yeah, I'm a big guy, but I'm no match for a bear. Um, Clint Eastwood said it best. And at the end of The Enforcer, or was it Magnum Force? Anyway, no, it was Magnum Force. A man's got to know his limitations. That's the studliest line I've ever heard out of Clint Eastwood. And it's true. If you know your limitations, you're not going to get yourself in trouble. So, but this reminds me of how lucky I am to not have to worry about blasting off the surface of the moon. That if that engine doesn't fire, I'm never coming home, right? But I have a lot less to worry about than these guys did. And this humbles me. I just hear his voice saying, quit your whining. You're on Earth. What can go wrong, right? And so it makes it fun. And plus it reminds me to look up at the stars. That I don't need to be reminded. When I go camping, that's built into the experience. In fact, I like to hike in the dark because it's cool if you're in a hot place. So that's how I control my environment when I choose to hike. And also, when you hike at night, it's really pretty. And you just have to be careful. There are a lot of different creatures that go about their business at night. They might startle you, but it's really not dangerous.
You take a flashlight?
I take flashlights, but I never use them. I hate those headlights. People coming in the other direction, they just want to see your happy face and say hi. I mean, it's nice and everything that they can see, a happy face. But I turn my back and say, sorry, I don't have a flashlight. I can't look into your light, but good to see you. And because if you lose your night vision, I hiked across the Grand Canyon in the dark with a new moon. So dark sky, you can see in starlight. You can when your eyes get adjusted. So it's really neat. And it can really be a problem when you see a bright light coming at you. So, but flashlights are a must. Always carry a flashlight. So that's Neil.
Thanks. We actually have some questions that have come in. Do you want to answer some questions?
Sure. Happy
Awesome.
to.
Thanks for sharing Neil with us. It looks like that there's a lot of kids watching tonight, and I think that was a big hit. So nice to meet you, Neil.
Good.
The first question that we received, is it possible to simulate the low gravity of space and the moon on Earth?
Yes, it is, but for very short periods of time. And the way we accomplish that for astronaut training, we can simulate reduced gravity for periods not exceeding 30 seconds. That's about how far we can free fall from high altitude in a jet that flies a special flight path called a parabolic path. And what they do is they go ballistic, literally. And ballistic, I'm going to define it for you. Ballistic is unpropelled motion through space. So if you throw a rock, it's going to travel and then it's going to fall to the ground. But if you put a rocket engine behind it, it can go farther. And ballistic flight is when there's no influence from any engine. So it's inertia that carries it, momentum carries it. So back to the question, what was it? I kind of lost track a little bit.
Oh, just a second.
Simulating gravity.
Yeah.
Reduction. Yeah, so every time you're on a roller coaster and it goes over the top and you feel that tingling sensation where you feel like your stomach's in your chin. And it's just really exciting feeling when you feel that. You feel that when you jump out of an airplane. So skydivers can experience that until they reach terminal velocity. Terminal velocity is when thickness of air doesn't let you fall any faster. So you're going to fall at about 120 miles an hour. When you open up your chute, it's going to slow you down to about 16 feet per second. And that's a safe landing speed. So yeah, they can do simulations in what's known as, some people may have heard, the vomit comet. That's the nickname given to the aircraft. There are commercial operators that will take you up so you can feel 0G inside an airplane. All the seats are removed, it's padded all the way around, and they train you on how to react during the free fall portion. And then they have to tell everyone, grab the floor, because when they pull out of it, you're going to feel 2Gs on the climb back up. So it's crazy monkey motion, but it's fun. It's like a carnival ride.
The
Yeah.
vomit comet.
The vomit comet. Amusement park rides for very short periods will give you that. So but going around Earth in zero gravity or microgravity, you know, that sensation, it's fun, but it's not good for your health prolonged. So you have to do a lot of extra
So we have
things
more
to
questions.
stay healthy. Okay,
We
that
have
was
a
a good
question
question.
from Journey. Yeah. We have a question from Journey, who's 8 years old and wants to know what causes the moon to look like it's changing colors.
Oh, that's a good one. Well, when you're talking about turning orange, that's air pollution in Earth's atmosphere, and what the sunlight goes through it, and it picks up that shade of red, and now it's a red light shining on the moon, or orange light. That's what causes the color change. And sometimes you get the reflection of Earth. We call that albedo, sunlight reflected off Earth during the night. So on a new moon at midnight, if you look up in the sky, you'll see the moon. It just won't be a bright white moon. It's because it's a little bit of sunlight and starlight that's reflecting off of it. And some of the light coming off the moon could be from, I don't know if we get our artificial lights on Earth actually get reflected off the moon. Our electric lighting isn't that powerful. It's just scatter from the sunlight. So you get different shades of colors.
Oh, that's awesome. Well, that's good to know. I know we're gonna have an orange moon. We've been having orange moons.
Usually it's orange when it's a lunar eclipse.
Okay, well, Alika also asked, who's 7 years old, do astronauts train in any special outdoor environments on Earth like Yosemite?
Not so much Yosemite, because Yosemite doesn't give you the discomfort of a harsh environment. It's posh with beautiful green trees and lots of waterfalls, and that's not anything like the surface of the moon. So you tend to want to go to a dry area like the deserts, and you also want to go to areas of geological interest. There are places in Colorado where they find certain types of rocks. But Colorado is mostly a good place for looking for fossils, things like trilobites and old shells and lots of course, dinosaurs. But yeah, so she was asking about.
Well, if astronauts train anywhere on Earth.
Yeah, they train in harsh areas. They tend to train in places like Antarctica because it's cold. So if you want to simulate extreme cold conditions or strong winds and storms, you know, Antarctica is good for that. But there's also a lot of geological interest. So they simulate being a geological technician, basically, in collaboration with geologists on Earth. They look for subject rocks to bring home, rocks that are interesting, that reveal some science and knowledge that we were oblivious to. So it's always a nice surprise when you find something new. And that's how we found out that the Earth is really a part of, the moon is a part of the Earth. Really, it's the same composition. And that helped us figure out that there was a old collision that helped create the moon. And it was a violent collision, and material that ejected from the Earth eventually accreted into a sphere and became spherical because of its gravitational pull on itself. And that's why worlds are round. And that's why bubbles are round too. It's the tension of the soap bubble that pulls in, and mathematical reasons why it's a perfect sphere. And it has to do with the volume to surface ratio being the highest in any solid object. That's what's unique about a sphere. So spheres are a good thing to study if you're a mathematician or a geometer.
Yeah, that's fascinating.
So everything you learn in school, let me tell you kids something. You have to believe me. I'm still a kid. I'm just 58 years old now. And everything they teach you in school that seems like dull or foreign, everything you think that you're never going to need in life that they're teaching you, you're going to need everything that you're learning and then some. Now that sounds daunting and scary, like, gosh, math is hard enough. You want me to build airplanes using things like calculus and, linear algebra and statistics? And I can't do that. Sure you can. Every smart person on this planet started as a young person like you. And it's up to you how far you want to go. And let me tell you, you don't want to slow down. You want to go as far as you can when it comes to education. It makes life a lot sweeter. It's fun, and it makes learning fun. The more you learn, the more you want to learn. So
Absolutely.
there you go.
We believe in lifelong learning at Chabot. That's one
Absolutely.
of our main.
Absolutely. If I could be a professional student, I'd be happy. So
Me too.
next
Well, we
question.
have some more questions. Yeah. So we have a question from 6-year-old Rosie, who says, if you ever got the chance to go to the moon, would you go? And what would you take with you?
Oh, I would take a camera for sure, a very high quality digital camera. And what would I take with me? Gosh, I wish I could take my dog with me. Now, my dog's getting old, so it's probably not a good idea to take him on a rocket ride. But when he was younger, he's been on motorcycles, airplanes, whitewater rafting, sailing, powerboating, everything I do, he does with me. And but he's blind now, so we don't do a lot of that stuff. But if I could, I would take my dog. And the truth is, the dog probably wouldn't like it. It's a fantasy. I think a dog is happier on Earth, and they wouldn't understand why things are so different. It might be very stressful, but definitely a camera. And I wouldn't want to leave. That would be such a special experience. I would go to the moon, absolutely.
I think I would like to go too. I think that would be amazing.
Yeah.
11-year-old, someone's 11-year-old asks, how do moonquakes happen?
Oh, moonquakes happen for some of the same reasons we have earthquakes. The tidal pull of the Earth is equal and opposite to the tidal pull of the moon. That attraction is mutual, and it's why we have all kinds of volcanic activities on some of the moons of Jupiter, and lots of moonquakes on the jovial moons. That's another name for the moons of Jupiter. And by the way, speaking of Jupiter for everyone, I want to say this. Young people have much better eyesight. As you get older, your eyesight declines. Okay, that's why pilots have to retire from flying airplanes at a certain age. And so your age may work against you, but while you're young, take advantage of your robust vision and do as much telescope viewing as you can, binoculars, bird watching, reading, and just recognize that your eyesight is perfect right now. So I was on a camping trip in Eagle Lake, which is near Susanville, Northern California. And I was there for 4 nights. And it's one of 2 places that I cried on the way home because I didn't want to leave. It was such a beautiful place. I saw 3 of the moons, the largest moons of Jupiter, and Jupiter, of course, with my eyes without any kind of binoculars.
Oh, wow.
There's no light pollution up there. It's high elevation, and I'll never forget that. And I've tried to do it since. I can't see all 3 or 4. I can see 2 maybe now, but it has to do with air pollution and light pollution. So you can see those things really well out there. But anyway.
Well, I think we have time for maybe 1 or 2 more questions.
Okay, I hope I answered that last question well. So.
Yeah, sounds good. So the next question is, how long does it take to get to the moon?
Well, that depends. Depends on how much fuel you want to burn. You know how we talk about flying airplanes at a slower speed, saving fuel? That's why the Concorde didn't survive, because it's not worth paying 5 times more for a flight to cut the flight time in half. You burn way more fuel than you need to. So if you can slow down a little bit, you can do things more efficiently. And that's why subsonic flight rules the skies commercially right now. Nobody wants to go faster than the speed of sound because it gets very expensive. That's why you don't want to speed on the highway. Not only is it dangerous, it's illegal. It can get you busted by the police, but it also gives you better fuel economy, so you can go farther, and it's better for your car. It's better for everybody. So paying attention to your speed, and that's how you do it. So if you go really fast, you have to burn a lot of fuel. That's expensive, and taxpayers don't want to pay that kind of money. The politicians start cutting off the money, and then you have to cancel the program. So you have to approach it with sensibility. So you go just fast enough so it doesn't take forever, and you don't go too fast so that you can't make it back because you run out of fuel. So it takes about a week round trip, 3 days to go there and 3 days to come back. And if you figure you spend a day orbiting, it's about a week. Apollo astronauts would spend anywhere from 10 to 11 days usually for the total mission. So yeah, it's 3 days of just sitting there like this in a little phone booth. So if you think COVID's a bummer making you stay inside your huge house, imagine sitting inside something the size of a Scion, and you can't roll the windows down. You can't go outside for air. Now, there was an Apollo Gemini mission. They broke a record. Americans broke a record on a Gemini mission with 2 guys, Jim Lovell and Frank Borman. They sat next to each other for 14 days. Can you imagine? 14 days in a car. Can't roll the windows down. And the body odor gets to be pretty bad. But after about 8 days of exposure to strong odor, you become immune to it. You don't smell it anymore. That's how lab technicians who work with formaldehyde and things like that get used to it. Ew. But yeah, that was a very tough challenge, and they wanted to know how astronauts can handle it, how the spacecraft interfaces with the astronauts and everything. We learned so much from that mission, and we applied everything we know from it. So.
Well, we have 1 more question.
Okay.
Actually 2 more. Let's do 2. So the first question is, there's a teacher who's wondering if there's a good website that you might recommend to teach children astronomy.
Oh gosh, there's so many. Take your pick. You know, I like NASA's website because there's something there for everyone, and the different levels of explaining it. And they have really good graphics. They have good computer simulations. Like you can do a simulated flight of the Curiosity rover's approach into Mars. I actually did a live demo of that at Chabot after the landing. So I showed them what actually happened. Everything that just happened, I explained in detail how the 6-ton tungsten weights had to be ditched and why, and so on. So there's a lot of engineering involved in that stuff. Yeah.
That's great.
So,
Yeah, I was just on the website today and they have a new simulator that you can go and actually do a moon trek, and they have actual footage that
mhm,
you can go and explore the moon. It's really incredible and actually see exactly
right.
what.
And I think they have Google Earth, I think, has some features where you can do like Google Mars and Google Moon. Those are great. And there's some really nice software programs that you can get, like Starry Nights, if you want to learn about astronomy. The best thing is to watch some of the TV shows about it, like Cosmos. There are ones that are better geared for young people that aren't too sophisticated. Those are good. But check YouTube. There's a lot of great stuff in YouTube. And people like myself, some with better skills and better equipment, uh, and go to some length to provide free information that's good and of good quality and accurate. So give YouTube a shot. NASA is always a great source, and if you live nearby Chabot, get involved. They have a really good program for science students called the Galaxy Explorers. Um, Take some trips to Chabot on Fridays and Saturday nights. I think they still do this. I'm not sure what the protocols are now with COVID, if the telescopes are open or not, but
Not at
I'm
the
guessing no.
moment, no, unfortunately, but we do have our virtual telescope viewings on
Hmm.
night 9:30 on Saturday evenings, and that's a really great thing to tune
Yeah.
into while we're closed up. And so that's, yeah, basically
Well,
plug in.
let's all keep our masks on and get through COVID safely, and when things open up, start visiting Chabot's telescopes and get involved. You can volunteer and learn a lot there too. So
Mhm,
um,
absolutely.
it's a great program, and go to planetarium shows because they show and tell everything interesting. Not everything, but whatever they're presenting at that time will go far in giving you knowledge. So, yeah.
That's great. You want to answer one more question?
Absolutely. I have as much time as you like.
Let's do one more.
This is fun.
So
Okay.
regarding going to the moon, do they bring extra fuel with them, or do they pack for exactly what they need? Do they plan for the exact fuel that they need, or do they take extra?
I got a good funny story about that. On the rehearsal for the Apollo 11, the first landing on the moon with Neil Armstrong and Buzz Aldrin, the crew that went before them did some testing of the lunar module, uh, but they couldn't go all the way down to the surface. NASA short fueled it on purpose. That means they didn't send them up there with a full tank of fuel. They didn't give him enough fuel to bring him home, so that if the astronauts like Gene Cernan, who was on that with John Young, if John Young would have decided to try to land the spacecraft, he would have become stranded. So it was a deterrent to make sure that the crew of the spacecraft don't say, well, this is a dress rehearsal, but heck, look how close we are. Let's just land the thing. That's what they were trying to avoid. They always have a margin of fuel for unforeseen events, like if they have to delay for bad weather their return, they can make adjustments to plan their return so that they experience the best possible conditions for reentry. And they can also decide the landing sites, like if the Pacific Ocean, which is a really good target because it's the largest ocean, that's why they chose it. They weren't very good at pinpoint landings. This is before GPS and a lot of good technology that would have helped, get close to your uh, landing spot. But uh, yeah, it's a difficult thing to plan for. You don't want to take so much fuel that it's going to get wasted, but you don't want to take too little. It's a delicate balance. Like I said, always take more food than you need. Not because you're going to bring it home, because what if you get stuck out there? You never know. It's good to have a reserve. That's why parachutists always have a reserve parachute. You can jump 200 jumps and never have to open a reserve chute, but you never jump without one. Spare tire in a car. How often do you get a flat tire? Not often, but you need to have a spare tire if you do get that flat. So the extra fuel you take is for, like an emergency. In Apollo 13, they were grateful for all the fuel they had. Without it, they couldn't have made it back. And they were very smart about how they consumed fuel. They used all the fuel out of the Lunar Module because the mission was compromised. It was a new mission getting home safely because they weren't going to be able to land because of the mechanical failure they had. It wasn't possible for them to complete the mission. So they used all that extra fuel that they weren't going to use to bring them home. And then they had a lot of extra fuel that they didn't need. It's good to have extra and not
Right.
run out. Like Thanksgiving, they say you should never run out of turkey. Can you imagine? Who runs out of turkey on Thanksgiving? Nobody. So you don't run out of fuel. Pilots who run out of fuel and make emergency landings often get punished for that because it's avoidable. So you can't say, sorry, I ran out of fuel. Well, you don't deserve to be a pilot. You'll suspend your pilot's license or they'll take it for good. So yeah, you have to do it by the book.
Well, this was so wonderful, Faride. Thank you so much for this talk. And
You're welcome.
all the folks tuning in have really enjoyed it as well. Definitely very insightful. It's great to kind of get into that creative world and imagine what it would be like to travel to the moon and exactly what it does take to get there. And now I'm ready to go on a camping trip on my own here on Earth. So
Good. Yeah, and when you go on your trips, always make sure that someone you know well and trust, usually family, if they're not nearby or not around, friends, somebody you can trust. Give them an idea of where you're going, when you're expected to be back. So if you're overdue, I take a lot of emergency equipment. I take a satellite beacon. Anywhere on Earth, within an hour, I get rescued. But it has to be a life and death situation. I mostly carry it because I expect to come across someone eventually who's going to need to be saved. And that's when you really need those things for. If not for yourself, it feels so good to save someone from danger. It's worth every penny. So don't think of it as an expense. Think of it as an opportunity to help someone in need. So I always carry it. It weighs 5.5 ounces. Every 5 years, it needs a new battery, but it sends a signal to the satellites. The people receiving the signal have on file all my information, and they'll make some phone calls to make sure that I didn't set it off by accident. And then they'll send emergency help, whether it's a helicopter or a sheriff patrol vehicle or an ambulance, anything. They figure you're in need, so they'll send someone. That's what I do because I don't want to be a statistic. So take precautions. Make sure you're thinking about your safety always.
That's really good advice. Well, thank you.
And the same with COVID. This COVID thing is dangerous, so please be careful, everybody. So
that's very good advice. Yeah.
Yeah.
Thank you again. That was a wonderful talk. Looking really wonderful to see you virtually and to see all of you out there virtually as well. Bye, Neil. Nice to meet you. Thank you all so much for tuning in tonight and for joining us this evening. Hope you enjoyed this presentation from Faride. And thank you for tuning in and tune in every Friday evening. We have something for everyone at 8 p.m. We offer a variety of engaging programming that you can enjoy and participate in from home. And also tune in every Saturday evening at 9:30 for our live virtual telescope viewing that is led by our resident astronomers. And when the weather is good, they are looking at everything from the moon to Jupiter to nebulas. It's really incredible and you'll learn a lot. While we work towards a grand reopening, we appreciate everyone's time and support as we find new ways to learn together. These events are fueled by you, our community. Thank you so much to our members, donors, partners for helping bring science to life for everyone at home. Right now, STEM education is more important than ever, and we need your help to keep these virtual STEM programs accessible for everyone. If you like tonight's program, please consider making a quick donation here on Facebook or through our website at chabotSpace.org. Help us power STEM education and launch the next generation of scientists, engineers, and innovators. And thank you to everyone who donated during tonight's program as well. We really appreciate your support. Thank you again, everyone, and we'll see you next time. Bye.